Greetings everyone. Welcome to the first part of this series on trig derivatives. Today we're going to learn the basic trig derivatives. So I'm just going to begin by going over them, and you'll notice here we have all the trig functions that you know right here. Okay, and I'm going to, over here in this column, I'm going to write what the actual derivatives are. Now you might want, once I'm done here, you might want to pause this video for a moment and write these down so you have them in your notes, because you will need them in class. Okay, so notice here you have the derivative of sine ax, or the original function sine ax. Well, its derivative, go with a little blue pen here, is a times cosine ax. Now this a is just a number, so this could be sine 2x, sine 3x, sine 8x, sine 1 billion x. And so what you do is you take the a value, whatever it is, and put it here, and then change this to cosine, keeping the ax again in the middle. Okay? Then the derivative of cosine would be negative a sine ax. Okay? The derivative of tangent, believe it or not, is negative a cosecant. Cosecant. What am I saying? It's secant, sorry. Okay. And it's not even negative. Ooh, oh boy. Good start, huh? All right. So this would be a times secant squared ax. Cotangent would be negative a cosecant squared ax. Secant would be a secant ax tangent ax. These are your derivatives for each one of these trig functions. And finally, last but not least, the cosecant function derivative is cosecant x. Oops, sorry. Boy, I can't spell tonight, huh? All right, cosecant ax cotangent ax. Okay, so these are the 6 trig derivatives that you are responsible for, and I will hold you responsible for. So you need to realize that. Okay, now what we're going to do we're going to do some examples now of this. Okay, keeping these guys in mind, we're going to find the derivative. Hopefully you will pause for a moment, write these down so you have them in your notes and can kind of follow along with our examples. Okay, so our directions are find the derivative. So number 1, we'll start with something basic. Y equals sine 3x. Okay, so its derivative then is going to be y dy dx equal to, well, the derivative of sine is cosine, but remember you take this a value and put it out front. So that would be 3 cosine 3x. All right, another example, 2. All right, let's say y equals tangent 2x. Well, then dy dx is then would it be equal to, take a look at the derivative, the list. What is it? That's right. It's 2 secant squared x. Now notice my little hint here at the bottom, and this is kind of important for us, this hint. If the original starts with a c, its derivative will be negative. Okay, so let's look at another one then, 3. Y equals cosine 9x. If I take the derivative, I get dy dx equals negative 9 cosine. What am I saying, cosine? Duh. Don't want to confuse you guys. Should be a sine. The derivative of cosine is negative sine. So we put sine 9x. Okay, so notice each time we take whatever this coefficient is and park it out front before we write the actual derivative. One more of these. Dy dx is equal to, oh, what am I saying, dy? We'll do that next. We need to know the y before we take dy dx, don't we? So let's fix that. Just rushing, that's all. So y equals cosecant 2x. Okay, so dy would equal -2, because once again it starts with a c, so its derivative is going to be a negative. Cosecant 2x cotan 2x. And this 2x, remember, just represents the angle measure. All right, not bad, not bad. So let's just do a couple more. Get my mouse going here. What do I want to do? There we go. Okay, so let's try, this will be number 5. Y equals x squared plus, cotangent x. Okay, well, that's pretty straightforward. All we do is we say dy dx is equal to 2x, because we take the derivative of that term, and then we take the derivative of cotangent, which is negative cosecant squared x. Notice this time the coefficient was 1, so that's really all I wrote there. See how nice that is? Let's do one more of this type, 6. Let's say y equals sine 2x minus cosine 2x. Okay, so let's take the derivative. Dy dx then would equal, well, the derivative of this would be 2 cosine 2x, and the derivative of this would be negative sine. Well, that negative will change that to a plus sign. So this becomes plus 2. Ooh, that's not a really good 2, is it? Plus 2. And the derivative of cosine is sine, so that would be sine 2x. Okay? Pretty straightforward. Well, let's look at one other type of example. I want to find the equation of the tangent line. Okay? So I'm going to call this example 7. Y equals cosine x at, we want to find the tangent line at x equals pi over 4. Okay? Well, you remember, to find the equation of the tangent line, we need to build this formula, our point slope formula. Okay, well, we've got our x1, that's the pi over 4, but we need a y1, and remember, to find y1 we just plug back into the original. So y1 equals cosine of pi over 4, which in this case is radical 2 over 2. Yes, you need to remember your trig values. Yes, you must. Okay, well, we also need the m, and how do we find that? Yes, the derivative. Very good. So the derivative of cosine, of course, is negative sine x. But to actually find the slope, we need to plug in the pi over 4. So we get our slope is equal to negative sine of pi over 4, which is also radical 2 over 2. Okay? So the equation of our tangent line is, let me make sure I write it correctly so no one's confused, y minus negative square root of 2, I'm sorry, y plus square root of 2. That should be radical 2 over 2. I'm putting the slope in. Duh. Okay, so y minus radical 2 over 2 equals, well, now you write the slope, times x minus pi over 4. Okay? Simple equation of tangent line. All right, well, thanks everyone. It's been a blast. Be sure you copy these notes down. See you later.